Welcome to the Introduction to the Entity Framework 4.0 live learning event brought to you by AppDev. Your moderator for today is Brian Ewalt. Brian will be available at all times to handle any technical issues or questions about the presentation format or software. Today's featured speaker is Visual Studio expert Robert Green. Robert will begin his 75-minute presentation shortly. If you have any questions during the presentation, please click on the Q&A menu and type in your question. At the end of the presentation, Robert will answer questions during a 15-minute question and answer session. Questions we cannot get to will be addressed on the AppDev Edge site in the Forums section. That address is online.appdev.com/edge. Finally, if you encounter any technical issues during the session, set your feedback to need help. Brian will contact you directly using Live Meetings Instant Messenger. You can also contact Brian by clicking on the Attendees menu found at the top of the screen. Simply click on the AppDev name and tell us about your issue. I'd like to introduce your presenter for today's event, Robert Green. Robert is a Visual Studio expert and a featured instructor for several of AppDev's Visual Basic and Visual C# courses. He is a former Microsoft project manager on the Visual Basic product team and Microsoft product manager for several products including Visual Studio, Visual Basic, Visual Studio Tools for Office, and Visual Fox Pro. In addition to being a successful consultant, Robert is a member of the INETA Speaker Bureau, and he has been a frequent speaker at technology conferences. To present Introduction to the Entity Framework 4.0, I'd like to go ahead and turn things over to Robert at this time. Robert?
Thank you, Zach. Good morning, everybody, or good afternoon, or good evening. Probably people who are watching this in the evening. We are live on the World Wide Internet Web after all. And welcome to this live learning event, Introduction to the Entity Framework 4. So we have a fair amount to cover. So what I'm going to do is hop over to the slides. I'm going to use the slides as sort of a overview, if you will. I'm going to use the slides as an overview. I'm also going to try to get the volume on. Is that better? Brian, how's the volume now? Better. Okay. Better still? I keep pressing the button with the plus sign on this. Okay, there we go. All right. Thank you. So we have a fair amount to cover, and I'm going to use the slides to introduce the framework and then review the things we're going to see in the demo, but I really want to spend as much time as possible in demos, because I'm sure that's what you want to see. So what we want to do is get an overview of the entity framework. We want to learn how to create an entity data model, because that winds up being the key. And then we're going to see various techniques for using LINQ To Entities to query data that's sitting in the Northwind database in the SQL Server. And we'll retrieve data, and we'll do some data modification, and we'll also see how to work with stored procedures. So what is the entity framework? Well, the good news is that it is part of the ADO.NET family of technologies, which means that it is not just another new data technology that Microsoft introduced, causing us to throw away everything we already know. It is built on ADO.NET. So it uses the same underlying plumbing. It is an evolutionary technology in the sense that it builds on what we already know. It was introduced actually in Visual Studio 2008 SP1, which means that we are now on technically the second version of the entity framework, even though it's officially the entity framework 4, because it ships with the .NET framework 4. So if anybody asks you, is this a mature technology, you can say, absolutely, it's on version 4. But literally, this is the second release of it. So anytime something new comes along, we ask ourselves the same questions. Why was this invented? What is it good for? And how do I use it? So why was it invented? What is it good for? The goal is to bridge the gap between object programming and database programming. What does that mean? Well, if you build an application, you deal with objects. So you have a customer object and a order object and an order detail object. And customers have related orders, so you'll have a collection of instances of the order class. Orders have details, so you'll have a collection of instances of the order detail class. And as you write the code in your application, you're typically dealing with objects. But to populate those objects, to actually go and get data, you talk to the database, which means SQL. So select columns from table, where, insert into, delete. So there's this disconnect, if you will, between writing against objects and writing against the database. Now there are ways that we can make that a little bit better. Type data sets were a good approach to do that, but there's still not this seamless model. One of the goals of the Entity Framework, primary goal, is to create more of a seamless way of programming. So I want to be able to talk to customer objects I create myself as objects. I want to be able to work with the customer table as an object, or individual customers as instances of a customer class. The key to this is the entity data model, where the entities represent your domain objects, customer, order detail, etc. Associations are the relationships between entities. So orders to order details is modeled as an association, and that's how one of the main way that LINQ to Entities, when you actually do querying, to be able to handle the one-to-many relationships. And then stored procedures or user-defined functions are known as functions in the entity data model. So the entity data model is an abstract conceptual model of data, which is in the entity framework not tightly bound to your data source or a particular application. And one of the primary differences between the entity framework and LINQ to SQL, for example, is that in LINQ to SQL, your entities have a one-to-one mapping to a single table. So you have a customers table in the database, you will have a customer entity. And by default, the columns, properties in the customer entity map one-to-one to the columns in the customer table. In the entity framework, you do not have this restriction. You can have a customer object that maps to the customer's table, and that will be very standard, probably the default. But let's say in your database you have a customers table and then a customer details table, because there is detailed information that people look up occasionally, so for better performance you strip that out and put that into a separate table. Your customer object can map to both of those. So in terms of your entities, you have a single customer entity that's getting its actual data from more than one source. You can also have your customer object mapped to the customers table on the SQL Server database, and then get the details from a web service, or a WCF service, or a WCF data service. It doesn't really matter. Your entity model has entities, and then how you get the data into them is plumbing. The entity data model has three components, and we will take a brief look after we create an entity data model at these. It's all defined in XML. It's just nice to know that it's there, not to spend a huge amount of time actually digging into the XML. The conceptual layer defines the conceptual model. So what are your entities and how are they related? And the XML for that is the conceptual schema definition language. Then there's the storage layer. So how is the data stored? That is defined by the storage schema definition language. And then there's a mapping layer. So that is what entities are storing what data. So you have your entities, you have the data stored in the backend data store, and then there's a mapping between the two. So again, this mapping layer is important if you're going to have an entity that gets its data from multiple sources. You know what the entity is, you know where the data is coming from, but how do you populate or hydrate, if you will, a customer object from multiple data sources? That's defined in the mapping layer. So the entity data model has those three parts to it, and as we'll see shortly, it's all XML. So the entity data model is the key. Then there is an entity client data provider, and it's the job of that to communicate with the data source, and then you're going to write entity queries, either in Entity SQL or what we're going to use in the demo today, LINQ To Entities, and then you're going to write these queries, but of course the database doesn't understand LINQ To Entities, the database understands select, etc., so you need something to translate the entity queries into the language that the backend understands. That's the role of the entity client data provider, and then it returns a data reader. And then you have another layer called object services, which is what literally gives you the ability to query using Entity SQL or LINQ To Entities. So you create a query, and then your entities get populated, and then object services is what keeps track of data modifications and change tracking. So you're able to connect to databases, send queries, modify data, all the things that you would expect. In your code, a key concept is the object context class, and it is the job of the object context class to manage the interactions between the data and your entities. So this is the thing that connects to data sources using the entity client data provider, retrieves information, sends changes back, tracks changes. So every time you want to query, you're going to need to create an instance of this class. You can think of it as the same thing as the proxy class when you call a web service or a WCF service. It is the code that, essentially the thing that, the runtime piece that does the actual communication with the back end. And then your entity classes are simply properties of the object context. So if I want to work with the customers table, I create a new instance of this object context, which on this slide I called LINQ Entities, and then customers, which is an entity, is a property of that. And stored procedures are methods of that. They return result sets. So we'll see a stored procedure called customers in region. I can pass to it a region, and that will return a collection of customers in that region. So I can talk to my entities as a property, so I can basically say in my LINQ query, the equivalent of select star from customers. For customers, I'll just use nwinentities.customers. Okay, so as we said, the entity class represents a domain object, and it has a property for each piece of information, which typically will be a column in the table, but doesn't have to be. Relationships are the one-to-many relationship. In data sets, it's handled by a relationship object in the data set. In the entity data model, it's handled by an association. And the nice thing about this is that relationships, when you get to writing LINQ To Entities queries, are handled basically by properties. So the customer class will have a property called orders. And that orders property is a collection. And we use the generic entity collection class to hold that. And then there's an attribute in there identifying the relationship. On the flip side, the child class has a property which references the parent class. So in other words, if I want the orders for a particular customer, all I have to do is say customer.orders. That property returns a collection of order classes. If I want to know the customer that placed an order, I can say order.customer. And that customer property will be an instance of the customer class. Which instance? The instance of the customer that placed the order. So it's, as we see in the demos, it's really, really easy to work with the child objects as well as the parent object. You store procedures, you create a function import, and that basically imports the stored procedure to the entity data model. And then, as I said before, if the stored procedure returns a result set, you can just call it directly as a method of the object context. And then, when you call the save changes method of the object context, you have two choices by default. You'll send an update or an insert or a delete statement back to the database, or you can configure the object context to use stored procedures. We'll see how to do both of those. So there are two ways to create an entity data model. You can do it in the command line, in the command prompt, using the EDMGen tool, or you can use the Entity Data Model Designer in Visual Studio. And two guesses as to which one I prefer. So that's a very high-level overview of the Entity Framework, and we're going to see lots of demos. As I said, I wanted to spend most of my time in demos, not so much in slides. So that's a high-level overview of what this thing is. What's new in the Entity Framework 4? If you've never used the Entity Framework 4 before, then this slide is meaningless to you. What difference does it make when things were introduced if you're brand new to the topic? If you've used the Entity Framework before, then this first bullet point is very nice. Entities and navigation properties have their correct pluralization. I'll show that in the demo. This saves you a bunch of pain work after you create your entity data model. You can now add foreign key columns to entities. So the difference between saying order.customer versus order.customer.id. Okay. Does not support for complex types. Excuse me. You can now create the model first and then generate a database from the model. This is something that LINQ to SQL has had all along. Entity Framework now gets this. That's very good, especially if you are starting from your model. Often you'll start from your database and generate the model, but you may want to go the other way around. Lazy loading is on by default. So if I bring down a customer, when do I bring down the orders? If I bring down a customer and I bring down all of the orders all at once, if I'm not going to use all of those orders, then that's some network traffic that I would probably want to avoid. Now, by default, you only bring down the orders for a customer when you actually use them. And then there's also support for POCO, or plain old CLR objects, in other words, classes you create on your own. On the first version of the Entity Framework, you couldn't just create a class and then add it to your entity data model. Now you can create classes, say in a data access layer, and make a model out of those. Okay, so again, the high-level overview. Let's actually do this. Let's create an entity data model. I'm using Visual Studio 2010 Professional. This is the shipping version of this. So not the release candidate, not the beta. This is the real live version. Let's create a new project. And I'm going to create an empty, I want an empty project. Where did the empty project go? There it is, blank solution. That's what I want to create. I'm going to call this Entity Data Model Demo. Entity Data Model Demo 2. Okay, so now, the reason I'm creating this as an empty project is I just want to show you how to create an entity data model. When we get to the demos, I have one already created. All right, now I'm going to add to this a new item, and I'm going to let's try this again. I'll just create this as a link to this application. Data model for real. Okay, so now I'm going to add a new item, go into the data templates, and select ADO.NET Entity Data Model. Okay, And I'm going to call this Northwind. And click Add. The Entity Data Model Wizard comes up, and it says you have two choices. You can create a model from an existing database, or you can start with an empty model. Let's choose Generate from Database, and click Next. And then it asks me for my data connection. I'm going to point it to Northwind. Notice the entity connection string. The connection string itself is similar, but we also have some other stuff in here, metadata. There's the CSDL, SSDL, and MSL. Those were the three components of the entity model. The storage, the mapping, and whatever the other one was. Okay, we'll save this as Northwind Entities. Now this goes out, queries the database, and says which objects do you want to include in your model. Let's use customers and employees and employee territories, orders, order details, and territories. And then notice these two checkboxes here. Do I want to pluralize or singularize? And do I want to include foreign key columns? These are both new in Entity Framework 4, and I'm going to leave those checked. Then I'll click Finish. And Visual Studio retrieves the information about the tables and creates my model. Let me zoom out so we can actually see everything. Fit. Okay, so employees, orders, order details, territories, customers. Okay, that's everything. Now, in the first version of Entity Framework, this entity here would be called employees, orders, order details. These would all be pluralized. And then you'd have to come in here and change these and take the S off. And then notice the navigation properties. Order is associated with a customer and an employee. Those would be pluralized as well. You'd have to come in here and singularize them. So that checkbox, which is now on by default, is a good thing. Also notice in the order table we have customer ID and employee ID. In the order detail table we have order ID. So these foreign key fields are now properties of the entity by default. If you don't want that, you can take it off. Okay, so here's orders. We have a one-to-many relationship between order and order detail. So one to many, and this is an association. Let's get the properties window out. Okay. So here's our order entity. It's an entity type. It's named order. The entity set name is orders. I have properties for each of the columns. And then again, there's this one-to-many relationship between order and order details. So the order entity has a property called order details based on the association foreign key, order details, orders. So this order details property at runtime will contain a collection of order detail objects, and it will contain the details for that order. The order class also has a property called customer, which is an instance of this customer class, and it contains the customer who placed the order. So to get, for example, the city of the customer who placed the order, I could say order.customer.city, as you'll see when we do the query. Okay, and then this we see is a one-to-many relationship. This is a, from order, a many-to-one relationship. Customers can have 0 or multiple orders placed. Okay, so now if we want to use stored procedures, let's connect up to the database. Store procedures in here for retrieving customers in a region, and then adding, deleting, and updating customers. And now in LINQ to SQL, if I wanted to add these store procedures, I could just drag and drop them. Can't do that in the entity framework. Because I'd take a little bit more circuitous route. So the easiest way to do it is to work with the model browser, which I need to get out. Windows Entity Data Model Browser. There it is. So now the model browser shows me my model and my storage. So Northwind model.store refers to the database. Northwind model refers to my entity data model. So here are my entity types. Here are my associations. In the database, here are my tables. So notice in the database, there are employees, territories, and employee territories. There's a many-to-many relationship between employees and territories. An employee can represent multiple territories. Each territory can have multiple employees in it. So this employee territories table is necessary in the database to map employees to territories. But in the model, I don't need that. An employee has a territories property. The territory has an employee's property. I don't need that intermediary table. Okay. Now what I want to do is add stored procedures. So what I'm going to do is update the model from the database. There's a couple ways I can do this. And I'm now going to add the stored procedures. I could have done this up front. I can also do this after the fact. So I'll add the add customer, customers in region, delete customer, and update customer stored procedures, and click finish. And now they appear here. So now I know they're in the store, but they're not yet in the model. So to get them in the model, I can right-click and add a function import. This brings up the add function import dialog. It says, what's the store procedure name? And does it return anything? Add customer doesn't return anything, so I'll leave this as none and click OK. And then notice in the model it gets added to the function imports. Now customers in region, I can right-click and add function import. I think you can also double-click on it. Yep. Now this returns a collection of customers. So I select entities and I say customer. So now this is configured to return customers. I pass in a region, it returns me a collection of customers. And finally, I'll add delete customer, an update customer, and now the entity model, the entity data model includes my stored procedures, also known as my function imports. Now I have my model. I think this is cool. Notice that there's also an option to generate database from model. So let's come into the Server Explorer and let's create a new SQL Server database, which I'm going to call Northwind Backup. Oh, that's the name of the database. I should probably put the server in here first, then create Northwind Backup. There it is. It has no tables at the moment. There's nothing in there. I'm going to generate database from model. And what Visual Studio does is it generates the DDL, data definition language, that will create this. I'll say finish. This is interesting here. The generate database wizard will overwrite the existing schema and mappings. Continue. And when I first saw this, the first several times I saw this, I said, well, yeah, all right, whatever. I had no idea what it literally meant, so I figured it can't be too harmful. Okay, so here's the DDL that's going to run. So I'm going to rename this, change this to backup because I don't want to overwrite my existing Northwind database. Now I'll run this from inside Visual Studio. What is this? Does it work? I think I can now. Execute SQL. Oh, that's what I want to do. I clicked wrong. Sorry about that. Okay, command completed successfully. If you right-click and execute SQL, it works. If you run the application, it just fires up the form. Okay, so now I have tables, including the employee territories, so the model knows about the underlying store and it recreates that. Now, if we go back to Northwind, notice that in the original database, the table was order space details. And when I create the model, it's order underscore details. That's what that warning was about. So if you create a model from an existing database, you create your entities. You then generate the model, generate the database from the model that actually changed the name of this entity. So the first time I saw this, it broke my existing code because I had a bunch of queries written, all of the demos that we're going to see today, written for order details, and then it renamed them. And this was during the beta, so I submitted this as a bug, and the team came back and said, it's not a bug. The generate database wizard doesn't support that type of round tripping. So the idea is you're not going to create a model from a database and then turn around and recreate the model. Recreate the database. So the general idea is you create a model from scratch and then you generate the database from the model, not create a model from the database, then turn around and generate the database from the model. So this renaming, if you will, of the entity class is what happens if you do that round tripping. So just be aware of that. Okay, so let's do a couple more things, then we'll write code. So what is this model? Go into the Solution Explorer, and we close this, and we open with XML editor. Here's our model, a giant bunch of XML. Here's the SSDL, which was the SSDL storage schema definition language. This is the SSDL content is here. I can see I have an entity set, customers, which maps to the customers table in the database. Here are my associations, which map to relationships in the database. So here's the storage layer. Here's the conceptual model. This is my entity. So here are all my entities and associations. And then here's the mappings where we map properties to column names. So you're not going to spend a huge amount of time in here. It is interesting to know that you could use maybe a third-party tool. The biggest benefit of this is maybe you don't like the entity model designer that Visual Studio ships. Maybe there's a third-party tool. If it generates the exact same XML, then you can import that model into Visual Studio and move on. That's really the biggest benefit there. Okay, then in addition, there's code. Of course, there's code. The key piece is the object context called Northwind Entities. And this has properties for customers. Okay, so customers is a collection of instances of the customer class. And then if we go down and find customers here, now I want to find customers, so let's go to definition. Here's the customer class. Has properties for each of the properties, customer ID, etc. And then also, scroll down further, phone, fax, email address, navigation properties. Here's the orders property, which is a collection of instances of the order class. And then if we go look at order, that's going to have a customer property, which is an instance of the customer. And then we know, how do you know what customer it is? Well, you just base it on the relationship. Okay, so that is the entity data model. That's how you create one of these. In this case, based on the Northwind database. And now we have the underlying plumbing to be able to do queries. Any questions so far? Any questions so far? Oh, all right. So, wonderful. We have our model. So what? What do we do with it? Well, what we're going to do with it is query the database, retrieve data, and modify data. And as I mentioned, there's a couple ways of doing that. You can use Entity SQL, or you can use LINQ To Entities. I would prefer LINQ To Entities because it uses the familiar LINQ syntax. So if you know LINQ To SQL, it is 90% the same as LINQ To Entities. And if you know LINQ To Object or LINQ To XML, then the basic structure is exactly the same. Once you know LINQ, you essentially know LINQ to anything else, including LINQ to SharePoint, which is a new feature in SharePoint 2010. So you can use the Object Services infrastructure to handle translating your LINQ queries to statements that the database understands, handling results, doing any data modifications, and LINQ To Entities brings back results, and they are a iQueryable collection in the standard LINQ manner. So, I'm going to go through these fairly quickly because I don't want to explain the demos on the slides. I'd rather spend time in code. So we will see examples of simple queries. So from identifies the entity set, where you're getting the data from. Where limits the results, that's an expression. Then you can bring back all or some of the columns by using select. And then, of course, you can order by to sort the results. You can use scalar functions, so bring back a single value. So how many times has this product been ordered? You can also use scalar functions to filter data, so bring back all customers for which it is true that the customer ID equals something. You can use aggregate functions to operate on a collection and bring back a single value, so sales for last year or number of customers in Spain, for example. We're going to be able to query related entities. So we can use the join clause, LINQ To Entities. So we could construct our queries on related entities by using joins, but as we have seen, we haven't seen it in action, but we've seen the mechanics behind which the entity data model already accounts for the relationships. So if I want to get the orders for a particular customer, I can just say customer.orders. I don't have to do a join. We can use lambda expressions. Lambdas are parameters that you pass to a LINQ query that are functions themselves. We can group, so show me revenue by year, and then we will see examples of joins, particularly to highlight the difference between inner joins and outer joins. Inner joins being only parents that have children. Outer join is all parents regardless of whether or not they have children. And then we can use the entity classes to modify data. So, for example, let's just skip to the code. If I want to add a customer, I can use the add object method of the customer's property. If I want to modify a customer, I'm just changing the property. If I want to delete a customer, I can call delete object, and then save changes, I call save changes. Okay, that is it for the slides. Let's go to demo. In the handouts, you have this project. The only thing you'll need to do you need to do anything? Properties, settings. Oh, it doesn't have everything in code. Alright, so I've got a model. It's pretty much the same model. I've got some extra things in here, products, categories. Well, I've got two extra things in here, products and categories. And then I have the same stored procedures. So here are my function inputs. And I'm pretty sure that I included the text file, Northwind stored procs. These are the stored procedures. So you can easily add them to SQL Server. And the easiest way to add them to SQL Server, just as an aside, you go to the Server Explorer, right-click, add new stored procedure, and then just paste this in here. And when you save this, Visual Studio will send this up to SQL Server. Okay, so let's do this. I'm going to open up the code, and then I'm going to run this, and we'll look at code next to demo and see how this works. Okay, so the first thing I want to do is run a simple query. Oh, here's a question from Charles. Does the entity framework work with Oracle? The simple answer is absolutely. The more complicated answer is, where do you get the provider from? Microsoft has traditionally provided AD.NET data providers for Oracle. They are starting to move away from that and relying on Oracle or third parties to create the provider. So if you have a working Oracle provider, the entity framework completely works with Oracle. The entity framework itself, the .NET runtime, doesn't care where the data comes from. All it knows is if you have a provider that you can plug in that understands how to talk to your back end, it works fine. So again, simple answer, yes. More complicated answer is, where do you get the provider from? If Oracle does a good job of supporting Visual Studio and providing a provider, get it from them. There are Microsoft providers. Who builds a better one? We would expect Oracle builds a better one since they have more interest in providing one. But get the provider. If you can't get it from Microsoft, you'll have to get it from Oracle or third parties. Okay. So that said, and again, looking at this code, I ask you, where's the data coming from? And the correct answer is, I don't know, and I don't need to care, because the code, in terms of somebody writing the code, of course you need to care, but for me writing queries, I don't need to care. I have this Northwind Entities, which is my object context. I create a new instance of that, and then my simple query is, from customer in nwindentities.customers, where customer.country is USA, select customer.company name. So right here is the beauty of LINQ. So I create my variable from nwindentities dot. Why do you do that? I had trouble before with IntelliSense on private static void test. And what I'm going to do is say endWin entities, new Northwind entities, and then I can say endWin entities dot. There we go. That's what I wanted. So here's customers, here's orders, order details, and the stored procedure or method names. Okay. I don't know why I didn't get that in here, but that's what I'm looking for. Oops. Oh, stuff on this. That would be why the output command would double in this. Okie dokie, so simple queries. My first simple query is from customers, where customer.country is USA, bring back the company names. And then if I want to see the select statement, there are a number of ways of doing it. Probably the easiest way is to cast that USA customers to object query and then call the toTraceString method, which will return the SQL statement that is being sent back to SQL Server. So select company name from customers where country equals USA. This is good for learning LINQ. It's also good for confirming that your LINQ queries are actually what you wanted. And so the results come back. So this USA customers is an iQueryable. I can loop through that, bar cust in USA customers, and then I write cust. Now, I said just bring back company names. So this USA customers is a iQueryable collection of strings which contains the company name. Okay, then for my second query, I want to bring back company name, city, and region. So I select new, and then I specify company name, city, region, and where country equals USA, ordered by region and city. And then when I loop through this, I'm just going to display the company name, the city, and the region. Okay. All right, so in my third query, I want to get a list of cities in Spain that have customers. So from customers, where country is equal to Spain, select city, and then wrap that all in distinct. And that says bring back a list of cities, and only bring back one of each. So that distinct part is being done on the server, not on the client. So the select statement is going back is specifying to the server, just send me one of each of these. Okay, let's look at scalar functions. So I want to bring back customers named Carlos. So I met a contact named Carlos, but I forget his last name. I forget what company he worked for. I just know his name is Carlos. So I'm going to bring back from customers where customer.contactName.contains, because contact name is a string. I can use any of the .NET string methods. So bring me back all contacts where their name contains Carlos, and there are the two Carloses, and hopefully the Carlos I met is one of these two. Okay. Let's do some aggregates. I want to know the total number of orders. So from order in orders, select order.count, and that will tell me the total number of orders I have, which is 833. Now I want to know information on product 7. I want to know the number of times product 7 has been ordered. So how many times in the order details table is there a row with product ID equal to 7? I want to know the total value. So I can, from detail and order details, where product ID is 7, select unit price times quantity, and then sum that up. Give me the average, give me the max, give me the minimum, and then display that information. So here's how many times it was ordered, total value of orders, average, largest, smallest. You VB developers, you can actually do all this in one query. In C#, you have to do it in 5 separate queries. The results come back the same. Okay. Am I going too fast? Is this good? Need to remember to look for questions. Any questions? Does the provider need to be a particular kind, such as ODBC, says Charles, in a follow-up to the previous question? It's really going to be OLADB. It will be an OLADB provider. Since this is ADO.NET Entity Framework, it's using ADO.NET behind the scenes, so the same Oracle provider you would use in ADO.NET should work exactly the same in the Entity Framework, since Entity Framework is using OLADB under the covers to talk to Oracle. Okay, let's work with related tables. So I want to see products in the beverages category. Where are we? Related tables. So here are products in the beverages category. So to see this, I can say var beverages from product in products where product.category.category name equals beverages. This, to me, is one of my favorite things about LINQ to SQL, LINQ to entities, because I don't have to do a join between products and categories. So I don't have to look at the category ID and link back to the category table. The model already knows how to do that, and the model already gives me a category category property. And then I can just talk to the properties in that. So product.category.category name is the category name for each product. So any product where the category name is beverages, bring back the name and the price. And really straightforward. All right, customers with 20 or more orders from customer in customers where customer.orders.count. Let's go the opposite direction. Customer.orders is the collection of orders for each customer. Just take the count of that. If it's greater than or equal to 20, then you're included in the result set. And then name will be company name, and count is that actual count, and I will display that information. So here are my customers who placed 20 or more orders. All right, let's look at lambdas. A couple things I can do with lambdas. First thing I want to know is revenue by beverage product. So for each product, how many times was it ordered, and what is the total for that product? So here's the query. From product and products, where category name is beverages, so give me the product, and then give me the number, which is the number of times it was ordered, order details times count, and then the revenue, product.orderdetails.sum, and then I put a lambda expression in here, quantity times unit price. So this O equal greater than says, here's a lambda expression from order details, get the quantity, get the price, multiply it together. That's a decimal, and it could be nullable. So quantity is unit price is a decimal, quantity is a short, so multiply those together and make it a decimal. And then that will give me the revenue. So now, for each beverage, I see the number of times it was ordered and the total. And I can do that all in a single query using lambdas. Another use of lambdas is just essentially the equivalent of a where clause, if you will. Here I'm saying return from orders the first instance where the order ID is 10530. If there are more than one order with order ID 10530, which since that's the primary key, shouldn't happen here. But if you're doing something other than the primary key, it's possible, then you wouldn't necessarily do this. But here, I'm getting the first instance of an order where order ID is 10530, and then I'm showing the order date, required date, shipped date. For readability, it might be better to use a where clause, but You can also use lambdas to do this as well. Okay, let's do some grouping. I want revenue by year. So, from detail and order details, I'm going to group detail by the year of the order date. So, that's detail, which is in the order detail table. Go back to the order, get the order date, get the value of that, and then get the year. So, year is is a property of date time, but to get to the actual date time, then I have to add in this value. It's the value of the actual property. So group by year into grouped orders, ordered by the year, which is grouped orders.key. What is the actual key that I'm grouping by? Descending order. Then in my results set, I want the year and the revenue. So here again is my lambda, unit price times quantity. And no, I have no idea why I didn't make this decimal like I did in the previous example. It seems to work anyway. That's interesting. Okay, so anyway, revenue by year and grouping. All right, let's do some joins. I want to see customers in Spain and how many orders they've placed. And if they haven't placed any orders, they're not listed. So this will return customers in Spain who have placed an order and the number of orders they've placed. So down here at the bottom, now at the top, since I scrolled up, is my results set. So here I can join. I don't have to, but it's nice to have the ability to join as well. From customers, where country is Spain, join orders on customers grouped by company name, and then my result set is the name of the company and the collection of orders. And then what I'm going to display in the header is the number of customers that I have, and then for each customer, the company name and the number of orders they've placed. And then what I've done here is I want to show you the SQL statement. This massive thing is what gets sent back to SQL Server, but the key thing to see here is that I'm doing an inner join on customers and orders. So there's an inner join there. It's also repeated here, inner join. So that is why I only see the customers that actually have orders placed. Now if I do an outer join in the next example, then I'm going to see there are 5 customers in Spain, and this one here, Fábrica Internacional Salchichas, I'm sorry for butchering the pronunciation, placed 0 orders. Okay, so here I'm going to retrieve customers, join orders on cost equals order.customer into grouped orders, and bring back the company in the grouped orders. So in this case, it's an outer join, and I can see in my select statement, joining customers to orders using a left outer join brings back all customers regardless. Okay? So you can feel free to look at this a little bit more in depth on your own. I don't want to spend much time since it's already an hour into this. But those are examples of doing inner and outer joins. Okay, so we've now queried the data to death. Let's start making changes. So the first thing I'm going to do here is bring back the current prices. So currently, here are what the products cost. So I'm just going to, from products, where the category name equals beverages, bring back the products, show the product name and the price, then loop through that and cut prices by 10%. So it's just a simple property modification. So at this point here, after I have looped through all of the results and change the price. All I've managed to do is change the data locally on my computer. Now, when I call entities.save changes, then the runtime translates that into the update statement, sends it back to SQL Server, which then makes changes, and then I'm going to display the new results. So I've now cut all prices by 10%. So to change existing data is nothing more than making a change to a property and then sending the changes back. Okay, what about adding? So let's add a customer. I'm going to create a new instance of the customer class, and I'm going to populate it, so big industries. Then I'm going to call add object of customer's property and add that new instance of the customer class. Again, all I've done at this point is added this locally. When I call save changes, then that will be sent back to the database, which will do the usual insert. Okay, so at that point, I now have big industries in the database. I've gone back to the database here and retrieved customers, and you can see that big industries is there with me as the president. Okay, now I want to make changes to this customer, so I want to retrieve that actual customer here, customer before. Again, I'm using the lambda to retrieve customer ID equals big, and I'm displaying that currently Robert Green is the president. I will change this to Ken Getz as the owner. And use Ken in a lot of my demos because we write courseware together. And then save the changes, then go back and query customer. We can now see that Ken is the owner. So Ken has taken over, and of course, driven the company into the ground. So we will now delete this. So I'm going to delete the object customer big. This customer big is the instance of the customer class representing that customer. I'm now going to delete it from the collection of entities, which removes it locally. Save changes. That sends the delete back to SQL Server, and that customer is gone. So if I want to add a customer, I call add object on the customers collection. If I want to delete a customer, I call delete object. Why I delete object on the entities collection? I don't know why it's not entities.customers.delete object. I actually never asked that. It's a little bit inconsistent, but that's what it is. And then to save the changes, I call save changes. Okay, we can modify related data. So what I'm going to do now is add a new order for a customer. And so I'm going to add orders and order details. First thing I need is information on the customer. So customer alpha key represents that customer. And then orders are placed by employees. So I need information on this employee. Then I create a new order. Order date today. Acquired date 7 days from today. The customer is customer alpha key. And therefore the ship name, shipping information defaults to the customer's address information, and the employee is employee 3. Okay? Then I add that to the collection of orders for that customer. Now, the first product replacing is product 7, so product ID 7, so I bring down information on that. Create a new instance of order detail. Product is product. Unit price is convert to decimal. I grab the price of that product. Quantity 10, discount 0. Add this to the collection of order details for this new order. Do the same thing for product 8. Do the same thing for product 12. And now what I have is a new order associated with that customer, 3 order details associated with that order. And now I save the changes, which will send that back up to SQL Server. Grab the order ID, which after I save changes will be updated locally. Okay, and then I can show the orders for that customer and here show the details for the last order placed. So I've now placed order 11078. No, here it is, 11081. Today is not March 10th, but it is May 5th. So here's 11081 and the 3 products that are part of that order. So I've now made the changes locally and sent it back up to SQL Server. Okay, that's awesome to say. So when I do the save here, where is it? Save changes, I'm sending insert statements. When I did the modifications before, I sent update and delete statements. What if I want to use these stored procedures? And let's go back to the entity data model, and let's configure this now to use stored procedures. By default, I'll be using, we use insert, update, and delete statements. I now want to use the stored procedures. I can do that in the mapping details. Okay. So I'm going to select customer. I want to configure to use customers here. So I'll select the customer object, customer entity, go into the, and then click on this. It's actually not table mapping, it's the stored procedure mapping. So I right click on my entity, select stored procedure mapping. Okay, so right now we are not set up to use any stored procedures, but I can easily say, what insert function do I want to use? So in other words, when I add customers, sorry. Did I add stored procedures to this? I swore I did. That's odd. Oh, that's what happens when I think when I regenerated the database from the model, I think I broke that. See? Another good reason not to do that type of round tripping. So really, the takeaway is generate database from model should only be used when you're starting from scratch. You don't have an existing database, you have a model. Okay, so what I did was I went into stored procedure mapping, and for the insert function, I selected add customer, and then there's a mapping between properties and parameters. Then for the update, I selected update customer, and then what I had to do is map original customer ID to customer ID. And then for deleting, I said use delete customer. It wants to know where the customer ID comes from. Okay, so that's what I did. So now I have configured the model to use the delete customer stored procedure to delete, the update customer stored procedure to update, and the add customer stored procedure to insert. Save this, build this, perfect, run this. Okay, so now I want to use stored procedures. In this first example, I'm using stored procedures. Remember, I added this customers in region stored procedure, which takes a region as a parameter and returns a list of customers. So because it returns data, I can just call it as a method of the object context. So I can call customers in region, pass in the region, and here's a list of customers in Washington. Now, let's add customers. So I'm going to add a new customer, and I'm going to call add object, and then save changes, and that will add this customer using my stored procedure. So then I bring back customers in Ohio, and I see Kentucky AAAAA Consulting, Don Kiley is the sales manager in Toledo. Then I retrieve that because I want to make changes to it. Change the company name, the contact title, the address, a whole bunch of changes. And then here when I call save changes, I'm going to use the update customer stored procedure to change the name to Kentucky Consulting. Don's now been promoted to vice president and the company has moved. And then finally get another instance, get an instance of it again, delete it, and save it. Now, yes, if I'm doing this all inside the same procedure, do I really need to get this instance, save changes, and then get the instance again? Probably not, but typically you're not going to make changes and then delete all in the same procedure. So just for completeness, I run this query every time to get the freshest version of the customer data, and then here I'm deleting it and saving it. Okay, so all three of these are done with stored procedures. Okay, so Azer asks, before save changes, changing the value would lock the database records? Aha. And the answer is heck no. Oh wait, is the question should you or does it? So if the question is, does this lock the database records? The answer is absolutely not. This is happening locally. I send a select statement to SQL Server and say, bring me back information on this customer. This is in local memory. This is just happening in memory on my local computer. The database has no clue what's about to happen. Then I save the changes. I send my update statement or call the stored procedure back to SQL Server. And that's the same thing as if you're using ADO.NET, of course. You're using a data set. You retrieve the data. Then you've got a local in-memory copy of the data. Send the select statement, disconnect the database. There's no idea what you're doing with that information sent back. It doesn't really care. It only cares when you talk to it. Here, when I call save changes, I'm asking the database to update the changes. Now, in between the time I retrieve the data, made changes to it because somebody else had made changes to it, of course. What do I do about that? I'll do the exact same thing that I would do if I was using ADO.NET or a web service or a WCF service or entity framework. It's all the same. Concurrence, how you handle and deal with concurrency is pretty independent of the disconnected scheme you use to work with data. So if that was your question, hopefully that was your question. I hope that answers it. If that wasn't actually your question, please ask it again. And I did it. I have now, actually twice in a row, I've given this talk and taken exactly 75 minutes to get through all the slides and all the demos and a couple questions. So this is now my best talk ever.
Thank you, Robert.
So that is the content. If there are additional questions.
At this time, Robert will now be taking questions from you. Please type in your questions in the Q&A menu found at the top of the screen. Robert will answer as many questions as time permits, and questions that we cannot get to will be addressed on the AppDev Edge site in the forums section, which is at online.appdev.com/edge. And before we move on to the Q&A, I'd like to invite you to attend our next live learning event, Introduction to Binding in Silverlight with Ken Getz. This free invitation-only event will take place on Wednesday, May 19th at 11 a.m. Central Time. If you are an AppDev Edge member, you are welcome to register at any time on the site, or you can watch your email for registration information for this event. Now to your questions.
Ready? Anybody have questions? If you have questions in the future, you can always email me, rgreen@ncwtech.com. I'd be happy to answer any and all questions related to any framework. If you ask a question that I don't know the answer to, I will ask other experts or friends at Microsoft and get the answer for you. So happy to answer any and all questions you have on this topic. Do we have something like select for update in LINQ? Maybe, not that I'm aware of. If it's in there, I haven't come across it. It's possible it's in there, but I haven't seen that. Now, does Entity Framework replace LINQ to SQL? Yes and no. LINQ to SQL is basically specifically aimed at SQL Server. It only works with SQL Server, so it's optimized for SQL Server, and it assumes the one-to-one mapping between entities and tables. And it is, you can think of it as a stripped-down version of the Entity Framework if you wanted to. The Entity Framework is the full-blown official Microsoft object relational mapping technology. Microsoft has announced that they are not going to be spending a lot of time on LINQ to SQL. They're going to focus mostly on the Entity Framework. So moving forward, all of the investment goes into Entity Framework. LINQ to SQL is still there. You can still use it. If you're wondering which to use, you basically check to see if there are features in the framework that you want that aren't linked to SQL. Certainly, Entity Framework is, I would say, more full-featured and therefore possibly a little more complex than linked to SQL. And is the one that Microsoft is coalescing behind. So, yes, it replaces it. No, it doesn't replace it since they'll coexist happily for a while. Can I convert an application that uses LINQ to SQL to use the Entity Framework? Only to the extent that LINQ to Entities looks very similar to LINQ to SQL. So you can take your LINQ to SQL queries and very, very quickly convert them to LINQ to Entities. You'll have to recreate the data model. Laser asks, what is the easiest way to handle the concurrency control of Entity Framework in LINQ? Oh. The lame answer would be the same way you'd handle it in ADO.NET. The more advanced answer would be, we could talk about various techniques for concurrency. I don't have a simple off-the-cuff answer, but I think that the basic idea is the same as anywhere else. Before you call an update, you could requery and then compare. You could, I don't know. There's various techniques, and it's a bit beyond our scope here. So I think that's a more general question about data access, so I'm going to point on it. When you call save changes, the method actually being called is update customer or database, asks Neiman. After I configured the object context, after I configured my entity model, I told it to use stored procedures. Then, when I call save changes, I'm actually calling update customer. So it's really a configuration issue. Before I configured it, when I called save changes, then I was using update statements. After I configured it and told it, for customers, use the update customer stored procedure instead, then it was using the stored procedures. You can probably, can you configure this in code? Can you bounce back and forth at will, or do you have to completely update the model? It's a good question. I wouldn't be surprised if you could configure this in code so that you could decide on the fly which one to use. Or if you want to go permanent, you can change it in the actual model. What are some of the differences between using LINQ to Entities and LINQ to SQL? I have a list at one point of what the differences were, but they're 90+% the same. I think the biggest difference between them is what's happening under the covers. In terms of the actual querying, there are a handful of properties which you can't necessarily use. I think I don't even remember them off the top of my head. But in general, they're pretty much the same. Okay, Daniel asks, when you've inserted a new order with a bunch of items, is the save data call atomic, or can I get half of the order inserted and the other half aborted because the insertion of an order item failed? There are two things you can do. What I did was I called save data once and I did an atomic update. You could certainly call save data after you insert the new order and then also call save data after each order detail. You can also wrap it all in a transaction, either at the data level or locally. I didn't cover transactions here, but of course Entity Framework has full support for transactions. So what you would do in a production application, of course, is wrap that in a transaction, call save data once, and then check to see if it failed. So if you do it as a batch, wrap it in a transaction. If you do it individually, you still wrap it in a transaction. So either way, you wrap that in a transaction. I just didn't do it in my demo. Okay. Do I not get a transaction automatically? You get a transaction automatically. Wonder. Don't know the answer to that. Do me a favor, send me an email, rgreen@ncwtech.com, and I will answer you. And then send me an email with this question. I'll send it back to you, and I will also post it on my Edge blog, which I haven't posted on in a while. I'm very bad about that. But I will answer that question on my blog. But also send me an email, I'll answer you directly. Does the Entity Framework and LINQ support query hints or table hints? I'm not familiar enough with those to be able to answer the question. But again, email me directly, rgreen@ncwtech.com, and I will ask one of my friends who knows. Okay, other questions? We've got a handful of minutes to go.
That concludes our live learning session today. Thank you, Robert, for sharing this valuable information with us, and I'd like to thank each of you for coming to this AppDev live learning event. A recording of today's event will be available to you. Please watch your email for information regarding that. And remember, if we didn't get to your question today, you can post a question in the Edge Forums area of the site, online.appdev.com/edge. Also, we'd like to get your feedback on today's event. Please take a moment to complete the brief evaluation that will be emailed to you shortly. And before we go, a reminder that our next live learning event will be May 19th at 11 a.m. Central Time, and we'll be covering Introduction to Binding in Silverlight with Ken Getz. Check your email or the AppDev Edge site for live learning event information. Again, thank you for participating, and we hope to see you at a future AppDev live learning event.